Hi and welcome everybody to Discovering Aura, Neo4j AuraDB with Michael and Alexander. Hi Michael, how's it going?
Hi, Alex. Good. Happy belated birthday to both of us, right? Yeah, it's going well. I came back from travels on Saturday, and I've
Hmm,
spent yesterday to kind of get back a little bit relaxing and chilling and spending time with the family. So
that
that was
sounds
good.
good. Sounds good. Yeah, this is
Yeah,
the first episode this year with the both of us.
exactly. Happy New Year, everyone.
Happy New Year, everybody! Month
Yep.
is already halfway through, but still, I mean, we had to skip last week, and so this is the first episode. So yeah, happy to be back with you all to discover AuraDB and have some fun with interesting data sets. So I'm excited. Yeah. So I had yeah. I had also a pretty relaxed weekend. Went to the mountains. It is very green there,
Nice.
so it is.
Yeah, that's true.
It's very unfortunate, but well.
Yeah,
Mm.
yeah, it's not what it should look like this time of the year, right? So
No,
that's
no.
definitely climate change being ahead. And I mean, if it's like 20 degrees warmer in January, right, you can imagine what it means in summer, like with
Yeah,
20 degrees more, and it's not looking good. And if you look at all the stuff that's happening with the lignin coal
yeah.
in North Rhine-Westphalia, that's really horrible. So very unnecessary
A
stuff
little
that's
bit.
happening. Yeah.
Yeah. Hi, John. Good morning. Thanks for joining. Thanks for joining everybody else. If you're watching
Yes.
this live, then yeah, we hope to entertain you a little bit and to show you how easy it is to get going with a Neo4j Aura instance.
Yep.
Um,
Let us know where you're watching from. So if you watch
yeah,
live, let us know where you're watching from. But if you watch it later on YouTube, feel free to share it also on Mastodon or Twitter or somewhere else or LinkedIn, so that we see that you're seeing it, but also other folks can see kind of or don't miss out on
yeah.
the streams as well.
Or give us a like or a comment on the
Yeah.
YouTube video if you
Yeah, you
watch this
can also
afterwards.
comment. You can also comment in terms of like what other data sets you want to see, right? So if
Mm,
you have ideas for data sets, also pass comments to the YouTube or Twitch videos as well, or share it on social, Twitter, LinkedIn, or Mastodon, somewhere else.
yeah, yeah. Add if you
Would be
share it,
good.
maybe add a hashtag Neo4j to it so we can discover it a little bit easier. But you don't have to, obviously. But if you do that,
Yep.
then we will have an easier time to find your sharings. But yeah,
Exactly.
I think we can get going.
Hmm.
Where do I click here? I get this out of the way.
Need to remember all the buttons, right,
Exactly.
Alex? After
Yes.
after so much time.
So yeah, this is what is going on. So let me give a quick rundown. So just in case you are fresh to this, or you have like me apparently forgotten how it's going. So the plan is we do a quick recap. What is Neo4j AuraDB free? I'll show this in a second. And we pick a data set. And like Michael said, if you have a data set that's interesting that you saw somewhere that you have available and you want to share, or you found interesting to discover and to try out with graphs, then let us know either in the comments or on Twitter or Mastodon. Send us an email, community page, neo4j.com, wherever you want. And we have a look at it for one of the future episodes. Usually what we do is we look at the data model, look at the data set, and then think about, okay, what kind of data model would make sense for this, and what kind of questions would make sense for this. What are interesting challenges maybe, but also what are interesting solutions or results that we can generate from this data set. And
Yeah.
after we've done so, we drive this knowledge into a model, and we create that model, and that model will become basically the graph, because that's how it usually works. In the graph world, your data model is your graph. So that's why it is so easy and so intuitive to work with. And yeah, we load and query the data set, and then we get going. What is Neo4j AuraDB free? So Neo4j AuraDB is a free database in the cloud as a service offering. So you get this for free all you need to do is register with your email address, and then you have one instance available to you. You can play with that. You can try many things with it. So it's very easy to play with it, to try things out, to test some stuff, to explore and work with graphs. If you do it for the first time, it's a great learning way. If you have done it for many times, it's great to have it available for you as a service, as an online graph database. Basically, you can use for your projects. It is fully Neo4j, so that means it's a full database. So there's no differentiation between what is Neo4j and what is Aura. Aura is Neo4j as a database in the cloud, as a database, as a service offering. It's limited a little bit, so the free version is limited to 200,000 nodes and excuse me, 400,000 relationships. So that's the only limitation you have. If you want to go out of that limitation, you have to pay a little money, and then you have various tiers depending on your RAM and your CPUs. But then you have basically, once you pay, there's no limit anymore. So that's only available for the free version. And you get Neo4j Bloom, Neo4j Browser, and the data importer as well. So that's the new workspace experience, basically all in one tab. It's available for you, so you don't have to switch between windows and stuff. So it's very easy for it. So if you want to try it out yourself, if you haven't done so, go on that page. I'll put that link in the chat, so you can get your own AuraDB instance up and running during the stream. And today, the data set we picked, Michael suggested, was the Stack Overflow developer survey data. So Stack Overflow is running or conducting a survey amongst their users, amongst every developer basically that is using Stack Overflow, and I guess that's more or less everybody. And they run this survey, and Michael has it up on screen. So let me switch over to here. And they have a couple of segments, a couple of things, and you can say, okay, what technologies are you using? What programming language are you using? What programming language do you like? What don't you like so much? Which environments do you work with and enjoy working with? Would you like to work with more? And all of these things. And from there, you they run this survey, and it's I don't know how many people did answer submit this year.
So it's up here. It's 70,000 people.
Yeah.
So we might even need to cut the data down a little bit because it's 70,000 people times 80 questions. So there's quite a lot of data in there.
Yeah.
And I have not looked at the details of the data. So it's a pure live stream, basically.
Yeah.
Going through the data, figuring it out as we go.
Yeah.
And I think this will be quite interesting. So because there's so much detail, we probably also will limit ourselves to some of the questions, not all of them, because otherwise it's too much. But of course, you can use the same approach and then explore the whole survey as well.
Yeah.
Either on your Aura free instance or on Aura Pro instance, or if you want to sandbox or something else as well. Right. Exactly. So that's the idea. And I mean, if you go through the survey, there's a lot of information there, right? So on how people learn, which is also interesting for us from a DevRel perspective at Neo4j, kind of how people or where they learn to code, what kind of details are kind of which kind of, where is this? Here, I think, where they work, if they are kind of buying technology, if they code outside of work, which is really interesting, right? So how many people code as a hobby? 72%.
A lot, yeah.
Community aspects, kind of what do they use as Stack Overflow, Stack Exchange, how often do they visit there? But also things like what kind of forums do they use to learn new stuff? Do they go to YouTube or Twitter or GitHub or so, right? And so there's a lot of information in here. Also in terms of like technology, how long have they been working and so on. So there's a lot of things like most popular technologies. So you see like programming languages, but also tools and so on. So there's a lot of data in here, right? And so this was published, I think, in December, if I'm not mistaken. And usually a few weeks or months after they publish the survey data, they also publish after they publish the overview, they also publish the survey data. So if you go to Stack Overflow Insights, you first of all see a graph visualization on top of here, right? So that's actually a very common thing that you see in a lot of places where it's about communities or networks of people or collaboration. Also, people love to use graph visualizations, either static ones or dynamic ones like this one here, which kind of connects to your mouse, and then you basically get connected to all the nodes in that network, all in close nodes. It's almost like a K nearest neighbors, right? So when you basically,
Looks like
my
it,
mouse
yeah.
is the node, and it kind of connects to the 10 or so, 15 nearest neighbors to the node as such, which is kind of nice visualization as such. And if you look at this, they have like surveys going back to 2011, so we could also load different surveys and then compare the results, which could be also an interesting exercise at some point.
Yeah, interesting to see the change over time. Now it's
Yeah.
more than 10 years then to see the
Exactly.
development.
Yeah. So it would be good to see kind of where did we make progress, where not so much, and so on. So for instance, things like gender representation or minority representation. It looks from anecdotal data that we're making progress, but if you look at the survey results, it's still very much skewed to a male community, which is really something that we all have to work on as such. The other thing is the different surveys also have different kinds of questions and different kinds of schemas. So you need to put in some work to make them work together. So I looked at this data a few years back, and it looked different from what we have today. So you need to watch out for like schema changes and so on.
Yeah.
But at least, so data is available. Stack Overflow is usually quite good in making their data available. We've also done an episode on actually pulling in the Stack Overflow data itself, like the questions and answers and users and tags and so on. And so they also make that data available as well via API and also as a dump. And here we can basically download the CSV data. And after we downloaded it, we can actually look at it. Let me make it a little bit bigger. With a tool that I mentioned a few times already called XSV, which is quite handy. So for instance, I can say, or they actually, you look at it, you find the survey results and the survey schema, which is basically what do the questions look like. Then there's also PDF in here. Show you. This PDF is basically representing what the survey looks like from the outside, right? That's basically what the PDF contains. And the data itself. So if you look at the number of questions, we can do XSV count survey results schema. So we see there are 79 questions. You also see this when you open the schema here as an CSV. So you see there's a question ID, question name, and then the text representation of the question. And then if it's kind of mandatory, I think, what kind of question it is, and then what kind of selector it uses, like at scale and other scales as such, right? So we can basically turn these 79 questions into nodes as such with all this information, and then connect the results to the responses as such to these questions, right? Okay. And then the other thing is the actually survey responses. So if you count those survey, like we have 73,000 responses. So if you multiply this out, this is a little bit too much. So it's 80 times 70,000, which is 560,000, I think, something like that.
Yeah, that's a bit
No,
much.
it's 5.6 million actually. Oh. Yeah, 5.6 million. So that's a little bit too much. So what I did is I ran XSV split. So you can do XSV split and then provide it with a folder. And then you basically just say, I want to have my split size should be like 10,000 per file or something like that. And then it, so you give it a folder. It just also called split and 10,000 files, and then in this work options, input, out directory. Size, sorry, it's called size 10,000, and then in our split folder we have like files from 0 to 70,000, and each of them is like 10,000 large. So we can take one of them and play around with it, and then if you want to import all, you would either run the whole file or you would process one after the other.
Okay.
Such.
Yeah.
And each of those files is now, if you look at them, is 10,000 rows, right? We can look at statistics. So we see for each of the fields that's in there, kind of what's the field name, what's the type. Some is not so interesting, min, max, standard deviation, and so on. So you see kind of what's in there. And so you see there's a lot of text content in here. So that's something that we need to figure out how to work with this. Also, some of them have a lot of different values. Some of them have only a few different values. And then we also see that some of these fields have semicolon separated responses. So if they have multiple responses, so like multiple choice responses, then they come together into one answer. And we basically need to split them out later as such, right? So the format is not optimal for import, but we'll make the best out of it. So I already created an AuraDB instance here just now, which is still empty. I downloaded the credentials for it as well, and which gives you one of these credential files that you can use. So you can here in
yeah, and again, don't forget, you need to save this, and you need to at least
exactly.
better download that file.
Exactly. Yeah. Download the file, and then you have the password in here and the file and so on. And so that's what we're gonna use. And after creating the database, which takes a few seconds, you can open the Neo4j workspace. If you rather want to use the traditional tools, you can switch between workspace and browser Bloom and importer in your profile. So in your profile, you can just go to a profile in the blue box. You can switch between workspace and the traditional tools as such.
Yeah, I think that's so they're more or less on par nowadays, but there's still some functionalities that might not be there in workspace, because workspace is in what's the current version? So it's
still in early access, basically.
It's in early access, exactly. So it's you might come over, realize that there's some features not there, which you were expecting to be there. Then you can go back to the classic view, or better yet, if you discover something that's not working, send feedback and give us information.
If you open
about
send feedback, then you can basically provide feedback, and basically then the PM folks from workspace will respond, and much of it is already being worked on as well. There's also a help panel. So if you're really new to Neo4j and everything, then when you create a new database in Aura, you can also use the Start Here one, which basically gets you through a guided experience, where then basically here on the right side, you have to get started with Neo4j guide, which takes you through graph modeling, graph import, querying, exploration, and so on. So which gives you an like step-by-step process through this. So if you open the help menu, then that guides you through this experience as well. Okay, so we got a bunch of CSV files that we want to add here. So let's add our downloads. We take the schema, and from the split, the first one. So this would be the full file would be 108 megabytes, and our split file is 15 megabytes that we're adding. So which gives us in the schema, which is pretty straightforward, we have the question ID, question name, the actual question, and then is it mandatory? What kind of question? What kind of selector is it? And then for each person or each response, we have basically response ID, and then for each question, one entry. So we have 79 columns here, basically, that are connecting to the question, right? Something that's a little bit unfortunate is that they didn't basically correlate or they don't have anything from the schema in this response file as such, which is a little bit unfortunate if you see this, right? So, for instance, employment. If you look at this question file again, let's see. So employment is here in the question name, right? But some things are not in the question name. So we need to basically look at probably via the question name to match the columns of the where's it here? The columns of the response names to the question names here, right? But for instance, S0 is not in it, for instance, right? And so we need to see kind of how well can we match this actually as such, right? So it's a little bit tricky. If you wanted to model this, we would basically have a node called question, which we can map to our schema file, right? Which has then question ID and so on. And then we have responses to this question, right? And like response to, right? And usually you would model this in a way that you say, okay, the response has a correlation to the question, and then we basically pull this in. And then you could say, okay, the response is actually the response ID, right? So each person has like a response, and then it could have relationships, for instance, to each of those question nodes. There could be also a 3-level structure where you basically have something like this, where here is, for instance, the respondent user, right? Who issues a response to a certain question, right? So, for instance, issued or something like that, issued a certain response to a question. So then this would also be an option where you wouldn't put the information what they answered on a relationship, but you would put the information what they answered on the intermediate node here, right? So that's kind of the options. There's some more options how you could model this, but that's basically mainly what you have. But unfortunately, as we don't have a good mapping here, that's kind of accessible from the values of the CSV. What I would suggest we do here in the data importer right now, we actually just import the nodes separately and then merge them together in Neo4j and with Cypher. Because you also had a problem with some of these answers being semicolon separated, which data importer can also not deal with. So for the time being, I would just say we have our schema file, which we map to the question, right? And our usually I would have put the question ID as the ID field here. But because we want to map these kind of headers here, I would probably put the question name as an ID. So we can also rename this. So for instance, we can call this, instead of QID, we can call it just ID. And this here we can just call name. Since and this false response is a true false, so that should be Boolean. And the type and the selector are strings, right? And here for the responses, we would map the response file and basically map everything to this. What we could do is probably do the following. If we wanted to do this more manually, we could do the following, that we say, okay, we actually create one node for each type of response, so or each question, more or less, right? So for instance, we could say, let's say we would create an employment node here, right?
Yeah.
So we would say this would be employment, and then we would basically map from this file only this one column, employment, to this node, and then map this basically back to the respondent. So we would also map the file here with the response ID, basically, right?
Yeah, we
so
could.
that's our response ID, and then we would map basically this relationship, like answered or issued or something like that, right? Answered.
Yeah, I guess with this we could directly make some categories, if you will, for some like the when you go back to the how the Stack Overflow themselves, how they present the survey, they had like a couple of categories, right?
Yeah,
and
I mean, this would be a single question, right? So because employment is basically, am I like full-time employed or unemployed or something like that. So we could basically say, we turn this one question into a node, which is basically the model that we had in the beginning. And then we would here, we would say, we would connect this to the employment question then later on, right? So we could, unfortunately, that's not directly possible, but that's something that we could then later, basically. But that would also mean we need to basically manually model all the questions as such.
Yeah.
Which would be more work. On the other hand, we could also say we select those questions that we're interested in only, and then pull them out. That would be also possible, right? So we could now also say, okay, we create a second one, for instance, for remote work.
Yeah.
Work. And then we would again take this file and select remote work here from this. And then here it would be answered again. Perhaps we should try this and see what it looks like. Such, right? Because these are like the question categories, kind of, right? And then we could basically pick a few. For instance, if you want to say here's code, for instance, as well. So we can pick a few, do the import, and see what happens there, and then see if what we can do out of this. Actually, perhaps that's not such a bad idea. So here's code. We put an answer here again. If any of you is interested in a specific answer, let's see. For instance, we could also do a database I've worked with and database I want to work with. So we can see this as well, because it's more relevant to us as well.
True. Yeah.
Database.
Do you want to now combine the two questions in this one category?
Yeah, it was actually that's actually a really good point. So we could say this would go into DDD database.
I think you're too far. Yeah, here it is.
Tools.
Stop.
Here.
Yeah, stop. Yeah.
So, and this could be a relationship worked with, so to say so, right? And then we can do a second one, which we give the same label. So we probably we need to call this like something like name or so, or database name or something like that. And here we would call it database as well. So we need to use two because the two fields have different different values, basically, different names, and we need to rename them basically to name. Right. So we can't just use one answer field, but we basically need to use two answer nodes, but with the same property and same ID. So in the end, it will merge them together in the database into one node, but then we have two types of relationship.
That's more or less a little hack we need to do when we work with the data importer. But now we have different. Isn't that going to be a problem if we have now not, instead of answered, a different relation?
Yeah, I was actually wondering perhaps we can do something like this as well, that we put it more into the into more information on the relationships, right? So because in employment, I think we could also call the relationship basically employed also, right? At remote, we would say something like work type also.
Okay. Yeah.
And then here we call this, for instance, experience.
Okay. Yeah.
Right.
It makes it a little bit more clear,
coding
maybe. Yeah.
Since or something like that. And then this we could actually call something like years, right? So it could be a general, and we would call this also just years as a name here. And then we could also say here we also have years code pro, which we could also pull out as an as a second one. And we basically, I think now I broke it. Let me pull out a new one. So if we call this also years, and we use not years code, but years code pro, and rename this to years again. And then call the relationship basically something like professional since or something like that, right? So coding since and professional since, and then this relationship automatically maps it to this, right? So we have a few now as such to import. And one thing that I wanted to see is, you see these not available fields here, right? So that where there's no answer as such. And in the configuration, I think you can say what you want to exclude.
Like, okay.
We can say not available, we want to actually exclude.
Yeah, because we don't.
It should not create relationships for the things where there's not available, right? We can probably also use space, and perhaps also none of these as in right. So there's, let's say, comma, none of these, comma. Let me do one for space and one for an empty string probably as well. This looks with the empty string.
If that were, yeah. Very interesting that they even have these empty.
Yeah. Okay. And now if you do run import, we should see the data being imported into database. And
yeah, that's maybe wait for this interesting comment from Edgar. Edgar says, it's been over 2 years since I used the tool, but really happy to see that I can start with modeling nodes prior to importing data. So yeah, that's a really big step, and really makes it much more easier to work with it all if you have if you create your model, you know what your model is because you are the expert of this, and you don't have to worry about, oh, how do I do it in
Yeah.
Cypher? How do I write the queries to load the data? You can skip all that and go from your model to a
graph.
view in graph, to view a graph exactly in Bloom, for example, in
Yeah.
in easy moments, and without having to worry about all these these queries.
Yeah, exactly. And if you don't know Cypher yet, or if you have forgotten how Cypher works, so you can get from data to graph exploration without actually having to know Cypher, which is really nice, right? So that's really good. And if you want to learn more, then in this input results, it also shows you what is the syntax for creating the constraints and also what's the syntax for creating the data. So it basically batches up the CSV into I think 10,000 or 5,000 records or 1,000 records, and then sends a JavaScript driver request for each of those batches and passes in the list of records from the CSV into the query as a parameter, and then unwinds this and then basically merges the nodes and sets the properties on top of them. And you also see this IDs to skip is basically the parameter that we put in for what to skip, basically.
Yeah.
Right. And here it's also like managing Boolean stuff and similar for some other as well. Right. And we also see how many nodes did it create for respondents, for employments, and so on. So we can see also, for instance, here for employment, it got 10,000 rows, but only created 56 nodes, right? And then if you look at the relationships for the employed, it actually created to these 56 nodes 9,900. So there's only like 98 that don't have a value of the 10,000, right? And for the other ones, it created 9,900 relationship to this 56 nodes. So there are 56 different responses basically for employment, and then it created that. Something, and then if you click on Start Exploring and it works, then you basically should be able to see an example graph here as well already,
right, cool.
which is really nice. So we have, for instance, here, that's the employment question, employed full-time, and these are like a subset of people that had exactly that response as such, right? And so, or for student, there are a bunch of them, and so on, right? So you see for the different ones, we see kind of the expressions, right? So not employed, not looking for work. So these are all variants of the employment nodes as such, which is already nice,
cool.
because then you can also, for instance, start correlating. For instance, if I want to see remote work and employment correlated, for instance, right? So I could say, let's say independent contractor, if we take this node, so we can actually dismiss all the other nodes, right? And then we would say we find also a remote node or a bunch of remote work nodes. Hybrid, fully remote. So if we take our contractor and our fully remote and dismiss all the other ones, then we can basically correlate between these two we can basically do this, and then it shows us basically how many people are both an independent contractor in our file and fully remote at the same time, right? So we see basically all the people that are connected between the two are both, right? So that's 2,400 people, which is actually pretty large as such group.
Considering that we
although
just
that's actually not true. What you actually want to see is actually something else. Let me do this again.
what you show is now
the others.
both, right?
That's kind of both expanded, right? So what we wanted to see actually is not both expanded, but if we zoom in here, oops. we can. I wanted to do reveal relationships, but it's because there's one in between. Can we do show this path or so? Let me select both again. Path, show this path. So that's one of them, right? So, but I wanted to see all of them.
Yeah.
So we probably want to say fully remote, then respondent, and okay, sorry that I didn't want to do this. Undo. Respondent, and then I wanted to do contractor, independent contractor, this one, right? So this is basically our pattern that we want to see. We want to see from fully remote respondent to independent contractor, and that's what I wanted to see. This gives us now 1,200 people as such, right? So if we
still
1,200, and that's out of the first 10,000, right? So that's
exactly
like more than 10% that are independent contractors, which are fully remote, basically, right? So you can see already correlations here as well. Right.
Although we don't know how the split was more or less arbitrary by the 10,000 number.
Yeah,
so
it was just exactly.
Yeah, after 10,000 nobody. I mean, it is not possible, but it's not what it is going to be like. But it could be that after the 10,000 nobody else did
exactly
submit to that anymore.
So the other thing that we now can do is basically connect in query the questions to the answers to the question nodes, and I also changed this now that the respondent gets actually all the properties imported, so that we can do some post processing and see if there are any other things that we want to split out, for instance. So I'll just run this in the background again. And while this is running, we can actually go to query, and in query,
this is maybe good to see that this just maybe more or less answered Clément's question. If importing can be scheduled, or if this is a one shot. So if you have a daily import or daily, if daily or monthly or weekly or whatever is your cadence, if you could do it again. So as you see, you can do it again. You can schedule it. You can
exactly. You can do it again manually, but you could also, as I said, copy these files into Cypher statements into a script file, and then run, for instance, Cypher shell from the command line, and then just pass in the script file. And there you would replace this unwind with a load CSV, for instance, and then it would say load CSV with headers from URLs as node record, and then the rest would stay the same, basically, right? And the same for relationship records. But now it failed for whatever reason. That's weird. Okay, but what we are interested in is actually the respondent. And it didn't create any nodes for our respondent. But it added 780,000 properties. So I think we should be good, because it did like the thing that I actually wanted to do, which is adding all the properties. So that means if we go here, something that actually changed that we were not aware last time, Alex, is that in browser or query, there's now an explicit refresh button here. So if you see this here down here, so currently it says no nodes, no relationships, but if I click refresh, then it basically goes to the database and asks for details. So that's something that we last time, I think, were confused by, that changed.
Yeah, that's new.
Yeah. All right. So what we can do now is basically to say we find our nodes, like for instance, employment nodes, and we also find our query nodes or question nodes where the name is employment. Right? And for instance, say this answers now the question, right? Node answers the question as such. And that's something that we can do now. And but we also have, yeah, let's do this. So this should give us 56 relations, one for each of these answers, right? So we could do the same for remote work, and it would be, I think remote work was the question here as well, right? Do we still have this? I think it was called remote work. The remote work.
Yeah.
And then years code pro. So we would say remote work. And then we would say years.
Code.
That's actually a good one because here we have years code. Because the label is years, because we gave it a label years basically, right?
Ah, yeah.
And so we basically need to connect both of them basically to the question. Right? And now if we take one of these questions, say the employment question. Just return them. So a single employment question, but if I expand it now, it has all the answers connected to it, right? And each answer now has, basically, if I go now to student part-time, it has now all the answers connected to it, right? So, and for whatever reason, it still has the not available.
Maybe there is not available in inverted, commas.
Oh, right. This is connected to the respondent, and it uses by default not the respondent ID, but something else as a label. That's why it showed NA. But we actually want to see the respondent ID as such, right? So that's kind of, these are students. And now you could say, okay, what else did this student answer?
Okay. Yep.
Right? So we now see basically the relationship, this student, which answered to the question employment for student part-time, is also working with a bunch of databases here. Why can't we see this directly here? MariaDB, MySQL, coding since 10. So we should have to actually turn this into the years thing into an integer. Work type is full remote, and want to use MariaDB and MySQL Postgres SQLite. So these database ones are actually tricky because these are now ones again that are semicolon separated, right? So that's something I said at the beginning. Those are a little bit tricky. That I would rather probably do in Cypher than in the data importer, because the data importer does not yet support splitting data within a single field as such, right?
Yeah.
So something that we can do easily here to fix stuff is, for instance, say the years. We just turn them into integers. To integer. Right, so that's pretty straightforward. So we just changed the 51 things to integers now. So that's pretty simple. This one is a little bit more tricky as such, right? So for those, so we can, if you remember, Alex, we did it back then, I think in the Goodreads episode.
I think I remember we did it some time ago, yeah, and we
basically found the ones that were there. So I mean, we can do it, right? So because we are live coding here, so if you say database, we say where d.name contains semicolon, right? So we see how many database ones. So we have 2000 semicolon databases, right? So ones that we need to split. So we would do actually an unwind, do a split of this name on a semicolon, right? d.name, and then by semicolon. So we basically get a list of names, right? So we actually can return, let's return not just the count, but d.name and the split as names. We would see this is kind of the name, and this is our list of split files, right? And then we would say we would for each of those split names, we would create a new node, right? Tool, where we say our name is now our new name. Let's call it new name. So we take this list and split it into its constituents, and then for each of those entries, we create a new database entry. And now what we need to do is basically we have to carry over the relationships from the old one to the new one as such, right?
Yep.
So we would say here, I would say give me, how do we do this best? Probably can do this up as a subquery. So we would find all the connections that the original database entry had. So we had an worked with, right? So we have a respondent who worked with database, the original one, right?
Yep.
This is our original relationship here. Well, what we need to do is we need to delete this rel, and we need to create new rels. So from this respondent, we need to now create an worked with all the D2s basically. So the old relationship needs to go for this respondent, and for each of the D2s, we need to basically create a new one as such. Right. I'm just wondering if we actually should move this in here and change this. Oh. It's a little bit tricky. So we can. So this would create our new databases, and here we would get rid of the relationships. Let's do this, right? And then we need to basically do the same for new worlds. And then we do the same with the other relationship type, which is basically
One,
two.
Yep.
And so we delete this old relationship and then create the new ones, two. And then at the very end, we can also delete the old database node because that's one that had semicolons, and then we don't want to have the ones with semicolons anymore.
Yeah, but we could do that maybe in the next step so we can see that it worked.
Yeah. Okay. So let's see what happens now. Right. So we create new databases for each of these entries, and then replace the relationships from the old database to the new database node as such. So, and it just needs to have an. Yeah. Oh, we need to return. So it basically did 10,000 updates in total now. So that means now in all our databases should have just one entry. So if I make this smaller and this bigger, so we should not have databases anymore that have more than one.
Except we didn't delete the summary ones. So
right, we need to delete the other ones,
now.
right? That's
but,
true.
Just to see, here are some of them, yeah.
So SQLite has now like a lot of relationships, right? So so that looks better because otherwise it would be always in conjunction with another database, right?
Exactly.
So from that perspective,
that's much more interesting to see
exactly
what's
individual ones. Yeah.
Individual, exactly. Yeah.
So what we can do now is basically the statement that we just ran. We just use this instead of doing all the stuff, we just delete. And it deleted 1900. So almost all of our nodes were basically
more than one.
multi-mention.
Yeah.
Multi-mentions, right? And if I now run this again, it should give us all the database. Only 17 database nodes are left, basically, and each of them should actually just have one name.
Yeah.
As such, right? So that's kind of how you would fix it after the fact, which is a little bit more effort. So it's actually much easier to do the same with the original data. So if I look at our original answers, let's say we do the same with tools also, or web frameworks. Let's say web frameworks have worked with, right? So if we pick one of our respondents here, match our respondent where r.web frameworks have worked with is not NA, right? Oops. Not NA, return R limit 5. You see here a bunch of, let's not return R, but actually web framework. So you see here's Angular, here's ASP.NET and ASP.NET Core, and here's jQuery, Node.js, and so on, right? So you see also semicolon separated ones.
Yep.
As such. And what we can do here now is you can basically just take the respondent and then split again the web framework by some semicolon. Right? Or we can actually just unwind this directly. So if it's only one entry, like the Angular one here, then it will still return one element list, basically. So we basically get one directly. And we would merge an web framework node. We say name is framework, singular, right? And so we connect this, and then we also merge the relationship from the respondent, and we call it work with again, right? With web framework. So you see, it's much easier to do it before than after the fact. So you don't need to fix stuff and delete old stuff and so on. You basically just take the data, split it up. For each entry in that list, you create a node, and then you create a relationship, right? Yep. So if you want to see
once the relationships are created, it's
if you want to see this, what this looks like is basically again this and split semicolon as framework. You see, this is kind of the entry, and here's the list with the 1 to 5 or so entries here, right? So some have a lot of different, so Ruby, Node.js, Elixir, Python, web frameworks, Ruby, Vue, is JavaScript as well, right? So that's what it looks like, and we basically take just this list, turn it into one row each, create a node, and connect it to the node, right? And if you run this, then it should pretty quickly create 25 nodes. So we have 25 web frameworks, 23,000 relationships, and that's good, right?
Yeah.
And then we have the second entry want to work with.
Yeah.
Right. So we basically and then we just change
1, 2. Yeah.
Just 1, 2, and then that's all that we need to do for doing the same here.
Yeah.
As such. And now if you look at web framework here, we see our 25 web frameworks with no duplicates, and we can then basically correlate people's, for instance, which 2 web frameworks have been mentioned multiple times by the same people or something like that, right? Or in pairs often. So we would say web framework, and then say worked with it would be in respondent, and then another web framework.
Yep.
And then we would say return w1.name, w2.name, by frequency, order by frequency, descending limit 5, and this would be like the top web frameworks that appear often in pairs, basically. And we probably also want to filter out where ID w1 is greater than ID w2. We don't get like R and B. So React and Node, Express and Node. The Node.js is not really a web framework, right? So which is kind of weird. Because Node.js is just a programming language or the main framework. Next.js and React. So that's kind of modern web frameworks, basically, right? So jQuery is a little bit more dated as such. But you can see also correlation. Now you could also correlate this with databases. For instance, here we could also say, I just keep the W2, so I don't need to change it, but I would say database here. For instance, which web framework with what database have most frequent mentions, right? So
okay, yeah.
Very obvious, because that's kind of built in, is ASP.NET Core with SQL Server, so the Microsoft world, basically. But similar, you would see MySQL with, or Postgres with React, for instance, right? So that's something also that's very common combination as such, right? Or Postgres with Node, or MariaDB with Laravel. So instead of MySQL, those people were using MariaDB, which is basically similar with Laravel or Vue, or so you can start also correlating things across the line. And so you can basically work your way through all the questions as such, which are a lot. And then if you created this once for one of the files, you can import the whole data for all the other questions as well. Right? And if you want to explore this a little bit more visually, then you can also use something like the NeoDash, the visualization tool that we've looked at a few times already.
Yeah, I can
right, so and then
look for the link.
So we can also, if you go to tools.neo4jlabs.com, then you have all the different tools that you want. And NeoDash could, for instance, if you paste this in here, Neo4j is our username, and our password is this. Just really quickly, we can create a new dashboard. Oops. Sorry, let me put this here in here. So secure web page, and then our password is here. And then we can, for instance, say we create a new dashboard. And we would say, for instance, something like web framework. And our result would be a bar chart. And our query is basically find the web frameworks. And then return web framework.name, and then basically the count how many people work with. Did work or worked with?
Worked with, I think.
Worked with, exactly. And then we do the same for want to work with, basically. So, and then we just return. That should actually be it already. Then we save this. And then you can already see here for the different frameworks. This is the work with, and then if we use the one tool, we can basically switch between the two visualizations as such.
Yeah.
Right. And you can use different kinds of charts. Instead of bar charts, there's also like stacked bar charts, I think, somewhere. Or other things. So for instance, you can also do something like an Sankey chart or like a sunburst chart or so to have circular representations. And I think the sunburst should also work with this one. Does it? No. I thought so. But you can also do the correlations that we've done manually. You can also do them via, there's no bar chart here. You can also do them via visualizations as well.
Yeah.
Right. So for instance, I could also say make this a pie chart, for instance, instead, right? So and then you see like the typical pie chart for the different web frameworks as well. Yeah. And so for the different questions, we could have different charts and then have basically one that basically is Stack Overflow survey here. And then, so that's
we have basically a
dashboard.
A dashboard for the results to make it a little bit more easier to digest and to look at what the individual
so
answers
it would basically you could represent or reproduce something like Stack Overflow did here with their visualizations as such, right? So because that's basically all bar charts here, right?
Yeah.
And then you can correlate also. You can also say, hey, I only want to see this for professional developers, right? So where we then have like the people that have at least so and so many years professionally or something like that. So we can add additional labels to the respondents that says this is a professional developer, this is a contractor or something like that. So we can also work with labels to enrich our data set.
And add individual filters, like you just said. I mean, you could say only people that have 5 years of experience or something, 10 years of experience.
Yeah, so when we want to, for instance, say we want to add an extra label to these respondents if they have professional experience, for instance, right? We could actually say set r.professional. And so we would say everyone who has a professional since relationship, right? Gets a professional. Or you can say, okay, I only do this if they have more than whatever X years of professional experience or something like that, right? So it's also possible. Then if I do this, then it would set basically our 7,300 labels, and then now we know that basically 3/4 of our data is basically from professional folks, and then we can say, okay, I want to only see this from professional respondents, and then you could say, okay, let's look at these professional people, right? And then and so on, right? So there's a lot of possibilities how you can enrich this data set as well with more detail. Or you can say, for instance, professional and employed, so you can have also multi-labels on the respondent, for instance, or is this a front-end or full stack or back-end developer or something like that. So you can also work with labels there to enrich the respondent information as well. So it becomes a more complete knowledge graph as such, right? And then and this approach of first loading the data in as just as fields to our node is basically something akin to ELT, which is extract, load, and transform, not the traditional ETL where you do extract, transform, and then load, but you load it in first, and then after the fact, you basically extract structure from the loaded data, basically. So here, one of our respondent nodes represents one row of the CSV file with all the details, right? You see even all the NA fields here as well.
Yeah.
And so here you could basically then say, I extracted the relevant information out of this single node as much as I need or as little as I need. I pull this out depending on what I'm interested in as such. Right. So for instance, here, things that are interesting for us from a developer perspective is where do they learn to code and online especially, right? So things like that. Cool. I think that's it for today. I think that was really good and interesting. And there's a lot more detail, of course, in this data. So perhaps you want to revisit it sometime as such. So that
yeah,
would be quite
that was very, very cool, very interesting. And like I said, lots more to discover, I guess, in that data. If you have played around with this, if you watch this afterwards and you have played around with it and found some interesting insights, let us know in the comments. If you liked it, also please give it a like on YouTube, so we know we have me produce something that is interesting to you. Again, if you see something, if you want something in particularly from us here in this show, then let us know also in the comments, or reach us on Twitter, Mastodon, or on the Neo4j community page, and we can have a look at this. Actually, this week is also a very packed one. If we now come to mentioning what's coming in the rest of the week, in terms of Neo4j live streams, I'm meeting Jesus in a couple of hours for Going Meta episode 12. So we conclude the full year, 12 episodes today in Going Meta. So that's happening later today, and actually it says 17th here, which is wrong. It is actually on the 16th. I need to change that. That's good that I saw this. On the 17th we have, because that's not possible, on the 17th is the Wardley mapping with Neo4j. So that's what we do tomorrow.
Really cool.
That's an interesting session with Tom from the Wardley mapping community. And on Wednesday, Will and I will continue with the Full Stack GraphQL Book Club, Chapter 7, on the 18th. So that's what's happening on
really packed week.
Yeah. For interesting streams. So if you're not subscribed yet, please subscribe to the YouTube channel so you get pings on when we go live next. And I'll change right away the Going Meta date, because this is clearly the right time. Yeah.
And if you can't get enough, you can also go to our notes videos. So if you go to neo4j.com/notes2022, there are all the videos from notes as well. And we've already got more than 30,000 views on those videos. So it seems to be really interesting for people. And you can also find them on YouTube itself. But here you can basically do sub-filters on all the different. For instance, if I want to see only the GraphQL videos, then I just click on GraphQL here, and then I get the sub-filter aspects that are interesting to you.
Yeah, yeah, that's super cool, and they are, very interesting sessions in there from all kinds of topics and from very, very interesting speakers across the world. So
exactly.
It's a great way to learn, to see, to explore what's going on around the world of graphs. So have a look at those videos.
Yeah.
Or join the live streams during the next days or weeks, because we do more. So join us there and be part of the live video content.
Cool.
All right. With that,
thank you so much, Alex.
Thank you, Michael.
See you later for Going Meta.
Exactly. See you later. I hope I'll see you there. Hope to see you if you're watching this now. Tune in again, and if not, then maybe another time. Thank you all for watching, and take care, everybody, and see you soon. Bye.
Take care, everyone. Bye.